Hello, today we're doing question 8, where we're given some arithmetic sequence U1, U2, U3. It goes onward, and we know that the sum of the first n terms of the sequence is given by Sn is equal to n squared plus 4n. So for question A, we'll start with part I, and we're asked to find the sum of the first 5 terms. So that means n is equal to 5. So we're essentially asked to find Sn, and we can use this given equation for Sn where n squared, where it is n squared plus 4n. So S of 5 will then be 5 squared plus 4 times 5, which will be 25, plus 5, which is 45. That's the answer for part I. Then for part II, part 2 of this question, we are asked to find U6 in our arithmetic sequence. So the way that there are several different ways that you can do this, but I will be using our first method, where we can say that for the sequence, if we're trying to find the 6th term, we can take the sum of the first 5 terms and that add the 6th term, and that should add to the sum of the first 6 terms. So since we have the equation for the sum of n terms in the arithmetic sequence, we can take the sum of the first 6 terms. We can calculate for it, where it will our equation is 6 squared plus 4 times 6, which will be 36 plus 16. Nope. Sorry, that is 24. 36 plus 24. So this will then, and if we calculate, we know 36 plus 24 is equal to 60. So if we rearrange our equation above, we can find U6, or the 6th term in the arithmetic sequence, by doing the sum of the first 6 terms minus the sum of the first 5 terms. So that means our 6th term will be equal to 60 minus 45, or 15. Now for our next question B, we are asked to find the first term in the sequence. So we can just find the sum of all the terms up to 1, which will make the equation 1 squared plus 4, which is just 5. And since the sum of the first term only includes the first term, then we can say this is also equal to the. So for our next question, we are asked to find an expression for un, where n is representing whichever term we're looking at, in terms of n. So we want the equation for each value in our arithmetic sequence. So to do this, we will use the nth term, the general equation for an arithmetic sequence for some nth term, and the sum equation. So from the previous questions, we already know that the sum of the first 6 terms is equal to 60, and from our previous calculation, we know that the first term in our sequence, U1, is equal to 5. So to find our general equation, we want to find D. And we can use that by using the sum of the first 6 terms and then isolating for D. So we can say that for using this equation, Sn, where Sn is equal to is 6, is equal to 60. We will say that 60 is equal to 6 over 2, and then 2 times the first term u1, which is equal to 5. So this becomes 10 plus n minus 1, and we're looking at the sixth term, so this becomes 5 times d. So if we continue, 6 over 2 becomes 3, and we will distribute this into our brackets, so we get 30 plus 15d is equal to 60. So then, if we rearrange our function to isolate for d, we can say that 30 over 15 is equal to d. Then d is equal to 2. Now that we know that d is equal to 2, we can use our general equation, our first equation. So we can say that un, let's use a different color, we can say that un is equal to u1, which we recall is 5 plus n minus 1 times d. And that will be, d, where d is equal to 2, as we just solved for. And that'll be our general equation for any specific term. Just to note, we can further simplify our equation, un, by expanding the 2 into the brackets, so that our equation then becomes 2n plus 3.